Hi everyone, welcome to OWASP AppSec. And today we're here with the builder sessions. And for the next 45 minutes, you will have Dagmawi today to actually talk about the topic abusing Cloud Apps 101 command and control. Before I introduce the speaker, I just wanted to give you a few things to go about for the next 45 minutes. I'll be the moderator for this session, so I will come up back again after he's done. So if you have any questions, you can post it down on the Whoa platform on the right side of the video, and we'll be taking those questions once after the speaker is done with this session. And there's no chat options available for the attendees on the Zoom. So if you want to post in any chat thing or any questions, you can use the Whoa platform for the same. I'll be looking at down all of the comments to bring it down to the speaker, and we can discuss that at the last 15 minutes. So we have the topic here as abusing Cloud Apps 101 command and control. And we have a great speaker here. He's a threat researcher at Netscope Threat Labs, and he's focused on cloud application abuse and cloud-enabled threat detection. So really, I welcome you, Dagmawi, today, and over to you for the session.
Thank you very much, Saman. That was a great introduction. I hope everyone is having a great time here at OWASP Global AppSec 2022, and we have a very exciting talk prepared for you today. So let's get started. Like Saman said, I am currently a threat researcher here at Netscope. Previously, I've held positions as a researcher, a software engineer, and as a developer at multiple companies. I have my master's in cybersecurity from Drexel University, and I also have an OSCP and various cloud certifications as well. My interests range from capture the flags, exploit development, to the study of cloud application abuse as well, which is a really nice segue into what we're going to be talking about today. So it is my hope that everyone attending this session today takes away 4 key takeaways with them. Firstly, what is Cloud C2? What is Cloud Command and Control? What does that really mean? Secondly, what cloud applications are abused for command and control in the wild, right? Is this even really happening? Is this tactic occurring? Thirdly, if this is happening, how can you simulate this in your corporate network so that you can see if the controls you have in place can detect this tactic? And then lastly, if you do have gaps in your security posture, what defenses can you put in place so that you have a more complete security posture and you can identify this tactic being used in your environment, right? So those are the 4 takeaways. Let's get started. First, start with talking about what Cloud C2 is. What do we mean when we say cloud command and control? Before we define cloud command and control, however, we need to take a step back and talk about what command and control is. So command and control is a stage in the cyber kill chain. The cyber kill chain, maybe for those of you who aren't familiar, is a set of steps an attacker uses when compromising a target system. And this was developed by Lockheed Martin. And it typically starts out with the attacker performing some reconnaissance. You can see this on the right side of your screen, or the slide, I mean. It starts out with some attacker performing some reconnaissance. They'll gather some information. Once they've gathered some information, they'll try to find any weaknesses they can weaponize a malicious payload against. Once they've weaponized this payload, they'll deliver it and then exploit that weakness. Once they've exploited that weakness, they will install a particular piece of malware on the target system that will phone back home and poll for additional commands. So this traffic where a compromised device is polling for additional commands is what we refer to as command and control. Traditionally, it has involved this, compromised device polling for commands via mediums like HTTPS and DNS directly to the attacker-controlled server. If you wanted to simulate command and control, you would have used frameworks like Cobalt Strike and PowerShell Empire to simulate this in red team engagements or penetration test assessments so that you could see if the controls you have would identify this. So now that we've covered what command and control is, what do we mean when we say cloud command and control or cloud C2? So traditionally, what we've seen attackers do is they'll set up their own infrastructure, their own servers, their own domains, and their own hosts to tunnel traffic through. And you can see this on the top right. A compromised device is going to reach out to the attacker-owned infrastructure that's set up by the attacker, which will then pull commands from the attacker machine, right? So this is what the traditional setup was like. This is tough to detect, but the security community has done a pretty good job of using threat intelligence feeds to identify this sort of infrastructure. So the the security personnel will identify a server that's used for C2. They will take this IP address or this host, they'll feed it to a threat intelligence feed that other security personnel can consume and then defend against if they see traffic to their network. What attackers have done is recently, they've started using, or I should say abusing, cloud applications as a medium for command and control, right? So instead of these infrastructure, we'll see Dropbox instances, Google Drive folders, right? Slack channels, S3 buckets as a medium to tunnel their commands back and forth. Now, why would an attacker want to do this? Well, firstly, it's very minimal setup. It's very easy to kind of get set up and going into these cloud apps, right? Secondly, they're very, they're cheap, if not free, so they're very cost efficient. And thirdly, it's even tougher to detect this traffic since everyone uses, they're so popular and ubiquitous, you blend in with the existing traffic that much more. So it's that much more enticing for attackers to use these cloud applications as a medium for C2. So what we refer to as C2 is actually categorized in MITRE ATT&CK as well. So MITRE ATT&CK, those of you that maybe aren't familiar with it, is a framework for categorizing the tactics and techniques that you see that attackers are performing in the wild. Cloud C2 is categorized as Technique 1102, or abusing web services for command and control. And it's broken down into 3 sub-techniques. The first sub-technique is bidirectional communication. And this is really what we're going to focus in for this talk, right? It's where the attacker is sending commands to and receiving output from a compromised system over a cloud application. So both the forward and the reverse communication is happening over a cloud application instance. Now, while we won't cover the other 2, however, it's important to mention them and know they exist because they are important. The second sub-technique is one-way communication. This is where the attacker will send commands to the victim or the compromised system without receiving any output back. So it's just the forward direction. This is you can think of it as another level of adding stealth from the attacker's point of view. They want to blend in and lie under the radar that much more. The third sub-technique is dead drop resolvers. For those of you maybe that are familiar with like spy movies and espionage, right? You know what the concept of a dead drop is. So you can think of a dead drop resolver as a digital dead drop, right? This is where the attacker is abusing the cloud app to host information that points to additional C2 infrastructure. So the communication doesn't actually occur over a cloud application, but the endpoint of where that communication should occur to or should communicate to is reaching out, is hosted on a cloud app. So here you can see a YouTube comment, right? This is an instance of a dead drop resolver where the attacker has left a message that says, my keyboard doesn't work, some gibberish. But then at the end of the second line is a base 64 encoded endpoint that the compromised system will pull down, decode, and then reach out to for additional commands. So that's kind of a quick introduction of what cloud command and control is, what we mean when we say cloud C2. Now let's talk about how often is this happening in the wild, right? What are attackers doing? How are they abusing these cloud applications? So here in this slide, it's a little bit of a busy slide, but what we wanted to show is the malware samples and the cloud applications they've abused for command and control. So we can see Boxcon, Nimble Mamba, and Crutch have abused Dropbox. Graphite and Blue Light have abused OneDrive. Aclip has abused Slack. We've seen GitHub abuse, Google Drive abuse, Twitter abuse, Tumblr, Blogspot, Google Docs, Google Script, Pastebin, OneHub, Telegram, right? And this is a select list. The list goes on. A much more detailed list can be found on MITRE's page, right? There's so much variety here and so many applications that have been abused that we really want to have you guys take away from this slide is that no cloud app is immune to this. Attackers have abused cloud apps or have abused the cloud app, or they are going to abuse the cloud app, right? It's either happened or it's going to happen, right? They're kind of diversifying and kind of gaining depth. That's what we really want to show here. So in the previous slide, we kind of showed the instances of malware and the cloud applications they're abusing. What we wanted to show in this slide is how we could can we get some aggregate insights from these instances. So we looked at our 23 known and reported instances of cloud command and control over a 2-year period from April 2020 to April 2022. And these are just known and reported instances, right? So there's likely a lot more that are not known or that have not been reported. But if we just look at the ones that are known and reported, we can see, we can get some insights. One of the insights is which cloud applications do these attackers prefer? And you can, if we take a look at that chart, we can see that Dropbox is by far the most preferred app at 8 instances of the 23. OneDrive is a second at 5, and then Google Drive at 4 instances. And then after that, you have Telegram at 2, and then Slack, Google Docs, Google Sites, Glitch, GitHub, Gmail, Cloudflare, and CloudFront all at 1 instance. So these attackers are kind of preferring these top 3 cloud apps the most, Dropbox, OneDrive, and Google Drive. And this preference is even more apparent if we go ahead and categorize these cloud applications based on the services they provide to their users. So if we categorize Dropbox, Google Drive, and OneDrive as cloud storage because they're cloud storage applications, we can see that cloud storage app is by far the most preferred by these attackers, right? At 17 instances of the 23. Then you have not so very close second, social collaboration and CDN apps at 2 instances each, web design, platform as a service, development tools, and webmail all at 1 instance each, right? So when we see a chart like this, when we see that cloud storage is by far the most preferred app at 17 instances of the 23, we ask ourselves, why is this the case, right? Why are these cloud apps preferred this way? And while we can't really know the answer until we sit down with these attackers and survey them and ask them why they made the decisions, what we can do is infer their reasoning based on the actions they took in the cloud applications. So we see that we came across 3 reasons that might likely explain what's happening. Firstly, how easy is it to get set up in these cloud applications, right? These cloud apps make it super simple to get set up, 3 to 5 minutes, and you have a fresh account and you're ready to go, right? Secondly, how popular and ubiquitous are these cloud applications, right? If you're trying to, everyone has a Google Drive account, right? Everyone has a Gmail account. If you're on a compromised system and you're trying to blend in to the existing traffic, you have a better chance of doing that if you're targeting one of these cloud applications. Or sorry, if you're using one of these cloud applications, right? Thirdly, and this is a trickier one, is how easily does it integrate to the existing workflow, right? We know that attackers are lazy and they're going to choose the easiest way to get to the goal, right? That's why they're the attackers. But when we take a traditional C2 type of setup that's been around for a while, and how does that work? They'll take the data, they'll encrypt it and encode it. This is a malware sample on a victim, right? They'll take the data, encrypt it and encode it, and they'll HTTP post it to their server. Okay, well, if they wanted to use a cloud storage app, what would have to change? They'll take that data, encrypt it, encode it, write it to a file, and upload it. That's 2 to 3 lines of code that needs to change. That's not that much at all, right? Versus you look at an application like Slack, maybe, what would they have to do? They would have to take that information, create a Slack channel, post it, reply, post it as a message, reply to that message, delete that message, right? It gets a little bit more complicated. And we've seen attackers do this as well. But what we also see, we also tend to see these attackers kind of choose the easiest way to get to their goal, right? And that's kind of why we believe cloud storage app is the most preferred. Next, we looked at the categories and which category is the most preferred, but what we also wanted to look at is where features in each category are abused, right? So when we look at cloud storage apps like Dropbox and OneDrive, we've seen uploading files, downloading files, deleting files. With social apps like Telegram, we've seen bot usage, right? We've seen reading messages, writing messages. With collaboration apps like Slack, we've seen creating channels, reading messages, writing messages, replying to messages. CDN apps like CloudFront, we've seen proxying traffic via CDN network. Web design apps like Google Sites, we've seen DGA-like algorithms to pass data to a different URL every day. Platform as a service apps like Glitch, we've seen creating custom applications and then uploading files to those custom apps. Development tool apps like GitHub, we've seen creating repositories, adding commits, deleting commits, right? Webmail apps like Gmail, we've seen writing drafts, emails, adding attachments, right? So the reason we have this table here is you can see that these attackers aren't taking their existing methodology and kind of shoving it into the cloud app. No, they're actually leveraging the features in the cloud application to kind of make their offensive workflow better, right? They're using channels in Slack, they're using repositories in GitHub, and they're kind of reaping the benefits of using these cloud applications as well. So let's talk about what we covered. So we talked about what Cloud C2 was, right? We defined what Cloud C2 is, and then we looked at some trends that are happening in the wild with regards to cloud command and control. Now, what we want to do is take a closer look and see how we can simulate this in our network so that we could see if the controls we have can identify this tactic being used. We're primarily going to use 3 tools to do this: Empire, C3, and Covenant, and we'll cover what those are in just a second. We're going to focus in on 2 applications here, Dropbox and GitHub. So Dropbox is a representative for cloud storage and GitHub as a representative for development tools. And for each of these apps, what we'll do is we'll talk about what is the cloud app meant to do? Why would an attacker want to use this cloud app or abuse this cloud application? We'll go over a real world example of abuse of this cloud app. And then for the bulk of it, we're going to go through a detailed walkthrough of how you can simulate this in red team engagement. And then finally, we'll briefly take a look at how this cloud application is being abused so that we can kind of see what's happening under the hood, right? So the tools we're going to use are Empire, Covenant, and Custom Command and Control, or C3. Empire is a PowerShell and Python 3 post-exploitation framework. It's open source and maintained by BC Security. It's Unix-based, so if you're kind of a Linux shop, maybe you want to use that tool. Covenant, on the other hand, is a collaborative .NET C2 framework. It's also open source and it's Windows-based. So if you're a Windows shop, maybe you want to prefer that one. C3, on the other hand, or custom command and control, isn't it's a little bit different from Empire and Covenant. While these other tools kind of focus on the command execution and interpretation portion, C3 kind of focuses on the medium the command is going through. So the definition is it's a framework for rapid prototyping of custom C2 channels. So it lets you kind of quickly get set up with new command and control channels that you want to use. And it provides integration with tools like Cobalt Strike and Covenant, so that you can kind of offload that command interpretation portion off to them. To develop and maintained by F-Secure Labs, they're great. All of these tools are very well maintained, and they're really a blast to work with. So if you have some time and you're trying to learn a new tool, I highly recommend you take a look at these. So first, let's take a closer look into Dropbox. So Dropbox is a very popular cloud storage application. And since it's a cloud storage application, right, it tends to be abused by uploading, downloading, and deleting encrypted and encoded files. It has a highly flexible app development interface, and it's very easy to get set up in Dropbox. It also exists as an enterprise and a personal cloud, and this kind of entices attackers that much more to use it, since the corporation they're targeting or the company they're targeting might be an enterprise level client of Dropbox already. So let's go over a real world abuse of Dropbox. So a threat actor by the name of Molerats was found abusing Dropbox for command and control earlier this year in January. This threat actor is known for being stealthy, and they've previously used this tactic of abusing cloud apps. What's really interesting here is that they actually used multiple accounts in this exploitation work, or in this offensive flow, right? And we can kind of see this flow along the right. Malicious Office document gets downloaded by a victim, executes some PowerShell code. This PowerShell code download and executes a .NET backdoor. This backdoor talks to the attacker, communicates to the attacker via these Dropbox instances, right? And the attacker kind of segmented or segregated these cloud applications based on their responsibility. So you had one Dropbox instance that's just for C2, another Dropbox just for file exfiltration, et cetera, right? So you can kind of see that they were separating these responsibilities out based on the account. So if one gets burned, they can still talk to the compromised machines. So how can we simulate this in our network, right? You can do this using tools like Dropbox, C2, C3, or Empire. For us, we're going to use Empire below, but that's somewhat arbitrary. You can really use any of the tools and achieve the same result. We're going to follow a 4-step process to do this. We are going to first create an attacker-controlled Dropbox account. Then we're going to go ahead and set up an Empire server, an Empire listener with an access token from the Dropbox account. So we're going to connect to the Empire server with the Dropbox account. And then thirdly, we're going to generate a malicious payload from Empire and deliver it directly to the victim, kind of simulate a compromise. And then once we have a victim, the attacker communicating via the Dropbox account, we're going to interact with the compromised device by tunneling commands through Dropbox. So let's get started. So firstly, we're going to go ahead and create the attacker-controlled Dropbox account and generate an access token. Here, we've signed up for Dropbox, and we can go ahead and create a new app on the platform. We're going to give it scoped access. We're going to say, you want full access to Dropbox, or to the Dropbox accounts, rather. We're going to name it Empire C2 and then give it, full read and write access. One thing that's not captured in the screen cap below is there's a place where you can download these, you can copy the access token. It's not shown on the screen cap, but we've grabbed that access token as well. And also you can kind of see a little legend on the top right that shows you where we are in the attack flow. So you can kind of see right now we're in the Dropbox portion, right? That's what we're setting up. Once we set that up, we're going to go ahead and set up an Empire server, an Empire listener with this access token. So we have a Linux machine here where we've installed Empire. We're going to set up Dropbox and give it that API token. If pass it the API token and everything's gone well, we can type in the execute command, and we should see that the listener Dropbox has successfully started. So we've connected this this Empire server, this Empire listener with the Dropbox account. So what does this do behind the scenes, right? So this is actually going to go into the Dropbox account and create a folder. Here, it's named Empire. That's the default. We didn't really change it, but you can change that to whatever you feel like is appropriate. Here it's created an Empire folder that has 3 subfolders: results, staging, and taskings. And this is really kind of laying the groundwork or the foundation for that communication later, so that the compromised system can reach out to the attacker and the attacker to the compromised system over these folders or over this application that's been set up. So now that we have the Dropbox account connected to the Empire server, and that's fully functional and running, what we're going to do is we're going to generate a malicious payload and deliver it directly to the victim to kind of simulate a compromise. Normally, in a red team engagement or maybe a pen test assessment, what you'd follow is, or what would typically happen is, you'd have a phishing campaign that you download, a malicious document or a malicious link file that then would download this as a next stage payload. We're kind of skipping all of that here just for the sake of brevity. We're just going to copy this payload over and kind of simulate what, compromise that has happened, right? So we're going to use the stager module in Empire. We are going to set the listener to Dropbox and generate that payload as a Windows batch file. We're going to name it launcher.bat. We're going to copy that to the victim, and we're going to execute that. Once we execute that, we should see a PowerShell process start up, and this PowerShell process is going to phone back home to the attacker and register what's called an agent, right? So this agent's going to have, an agent name. It's going to have the language information about the IP address, the username it's running as, the process name, process ID, the delay, the last time it was seen, and most importantly, the medium it's communicating through, which is Dropbox in this case. So we have, once you set all of that up, we can interact with the compromised device. We have a quick video here. Let's see if this will play for us. Okay, cool. So here we can see, so what we have is we have the victim machine set up, and we've copied this batch file, or this Windows batch file, over to the victim machine. We've named it launcher.bat, and we're going to go ahead and execute that on the victim and see what happens. So once we execute that, we should see two PowerShell processes have spun up, right? And we go to the attacker screen. What we see is this agent will check in, right? And it'll have a unique agent name. Since this is a multi-stage deployment, it does take a while for the agent to get fully set up. So if we kind of list it out, it's still not kind of completely set up yet. Just give it 1 or 2 more seconds. You can see that it's now fully set up. We have all the same details as before, the agent name, the language IP username, process name, process ID, the delay, last time it was seen, and the medium, right, the listener. So we're going to go ahead and interact with that agent. We're going to type 2 commands. We want to see who we are and a list of the processes. One thing to note here is that the victim operates on a polling architecture, which means that it reaches out to the Dropbox folder to look for new commands at a specified interval. This interval is specified in this delay column here. So here it's 60 seconds. So so this means it's going to check commands, or the victim's going to check commands in the Dropbox folder for 60 seconds. This is important to note because if you set this to for once a day, you might not see the results of the command right away. So here we just have to wait a little bit until the agent checks in. But if we look at the Dropbox account in the meantime, what we see is how this communication is happening, right? You see that the attacker is going to upload these text files. The victim's going to download them, delete them, and then upload the results of these operations as different text files, right? And then the attacker is going to pull that down and then parse and show the results in that console. And it's also the agent names kind of lines up to the name of the text file in this case. All right, well, that kind of happened quickly, but you can kind of see the list of the processes that just came up, right? You see the process name, the process ID, the architecture, the username it's running ads, and some memory information, right? So now what we want to do is if we go back to the victim, what we want to look at is, so this is an application called Fiddler. Maybe those of you that aren't familiar with Fiddler, Fiddler is a web proxy that we have running on the victim machine that'll show us the processes and the web connections that's originating from these processes, right? So here we can see that this PowerShell process is reaching out to dropboxapi.com, and it's, gathering some information on, these encrypted and encoded text files. And if we try to see what the contents look like in one of the requests where it's trying to download these files, you can see that it's not legible, right? It's completely gibberish at this level. Awesome. So what did we just see, right? We saw how this interaction is happening between the compromised device and the attacker's machine, right? This interaction is happening by uploading and downloading these encrypted task files. You can see on the left side of our screen, these text files. If you try to download it, open one of them, you can see that it's not legible at all. It's encrypted. And if we take a look at the code, we can see that the portion of the code that's actually doing this is using an advanced encryption standard algorithm to kind of encrypt that data that's going back and forth. So let's summarize what we just talked about, right? So Dropbox is a cloud storage app that's similar to, OneDrive and Google Drive. It's abused by uploading, downloading, and deleting these encrypted files. If you want to simulate a threat actor using this technique, you can do that using tools like Dropbox C2, C3, and Empire. And one thing to note here is, depending on maybe the sophistication level you're trying to model, you can use these tools differently. So if you're trying to model an unsophisticated threat actor, a threat actor of low sophistication, you can use the default configurations of the tool like Empire or C3. If you want to model a moderately sophisticated threat actor, you can do that using, you can take these tools and customize their configurations a little bit so that you can kind of fly under the radar a little bit better. And if you want to model a highly sophisticated threat actor, the kind of attacker that we've seen targeted attacks in the real world, what you might do is use multiple accounts with segregated responsibilities so that the data transfers separated amongst them, right? You might also really tune your traffic to match what's happening in the network. So if you hop onto a victim network and you see that there is one person that uses Dropbox a lot, and that person's in HR or whatever, maybe you want to use that person's machine to kind of tunnel your commands outside of the network, so it kind of blends into that traffic a little bit better, right? Cool. So now let's take a closer look into GitHub abuse, right? We're going to follow a similar structure here as well. GitHub, maybe those of you aren't familiar, is a code development platform. It's primarily a source code repository platform, but it's grown to be much more than that at this point. And since it's really a source code repository platform, it does tend to be abused by creating repositories and adding commits. Similar to Dropbox, it also has a very flexible application development interface that lets you kind of quickly get set up and get going, and kind of use this app as you might need, right? If you take a look at a real world abuse of this app, when we saw Lazarus APT, or a very sophisticated North Korean APT, it's very famous, leveraged GitHub for C2 earlier this year. So the attack flow is very similar to what we were seeing at that given time. A malicious office document gets downloaded. It does a bunch of other malicious processes stuff, right? It spins up folders. It does some malicious link stuff, malicious DLL stuff, but it also communicates out to the attacker via a GitHub repository, right? And what it does, it retrieves the files present in the image directory of a GitHub repo, and then it grabs the commands from those files, executes the commands from those files, and uploads the command results. The command results are committed to the repo under the meta files directory, where the file name denotes the time at which it was executed. So it kind of really gets its money's worth from the GitHub account it has set up. So if you wanted to simulate this, how would you go about doing that? We did this using C3 and Covenant, and we followed the steps that were outlined by AppSecEU. It's a great set of steps. We kind of slimmed them down and kind of summarized them into that same 4-step flow we followed for Dropbox. These 4 steps are: firstly, we're going to sign up for this GitHub account, and we're going to create this access token, or create a personal token. Once we have that, we're going to set up C3 and Covenant with a GitHub channel, right? And we're going to use the steps again outlined by security. Steps are kind of much more detailed, right? They're like, clone this repo, set it up this way, pass these configuration parameters, etc., right? We're going to follow those steps to set up C3 and Covenant. Once we have those 2 set up, we're going to generate a malicious payload that contains this GitHub token, and we're going to run this on the victim machine to simulate a compromise. Once we have simulated this compromise, we're going to interact with the compromised device by tunneling commands through GitHub. And you can kind of see this in the attack flow, the chart at the bottom, right? The C3 server, the gateway, is going to upload those commands to GitHub. The malicious process, or the relay that's running on the victim server, is going to pull those commands down, execute them, upload those task results to GitHub. Then the gateway is going to pull down those task results, parse them, and show them on the console. So let's follow this first step and sign up for a GitHub account. So we'll sign up for a GitHub account. We go ahead and create a personal token. We're going to name it C3, and we are going to give it full access to this account, right? Once we have that GitHub account fully set up, we are going to set up C3 and Covenant with we're going to set up C3 and Covenant with a GitHub channel using these steps, right? The steps that were we referred to earlier that were outlined by AppSecEU. One thing to note here is that C3 and Covenant are, 2 separate repositories that are maintained at different paces. So if you set these up together, we found that there might be some compatibility gotchas. So to solve that, we found that the best commit hash is that commit hash from Covenant. That works pretty well for all our use cases that we mentioned here, right? But we're going to set up C3, and then we are going to go ahead and generate that. Once we set up the gateway, what we're going to do is set up the GitHub channel as that medium. And if we have that set up, we can see that on the screen on the bottom right. That's what it should look like, right? You have the gateway, which is the C3 servers connected to the channel. So what does this do, right? Similar to how we saw with Dropbox and the Empire folder being created in Dropbox, in GitHub, this is going to go ahead and create a repository to be used for the C2 channel in the GitHub account, right? So this repository is named DE5J. You can kind of see that it resembles any GitHub repository, right? It has a README, etc., right? So we're kind of laying that groundwork here, similar to how we did with the Dropbox account. So once we've set up the GitHub account and it's communicated to connected to the C3 gateway, we can go ahead and generate this malicious payload. It'll contain that GitHub token, and we're going to download that and run it on the victim machine. So here, C3 has this really amazing interactive UI that we can go ahead and create and download what we call a relay. So the relay is kind of that malicious payload. We're going to download that relay, copy it over to the victim machine. Again, we're going to skip all those other important steps for the sake of brevity, right? And we're going to run it as admin on the victim machine. So what this does, once you run it on the victim machine, it's going to spin up a process that's going to phone back home through GitHub, and it's going to kind of set up that the connection that we need to kind of tunnel commands back and forth. Once we have this set up, we can type commands like, who am I? That'll tell us who we are, and then get the current directory, which is going to give us details around where we are in the machine, in the file system, right? So how this kind of flows, you can kind of see on the right side, the gateway or the C3 server is going to send those commands through the channel. So the channel is like those two squares in the middle, the purple and the black square. And then the victim on the far side is going to pull those commands down, execute them, and then upload the results back through the channel through GitHub, right? So both the victim and the C3 gateway, they're both on internal networks. So they don't communicate to each other outside of GitHub at all, right? So we said that they abuse GitHub or they communicate via GitHub, but how exactly is this happening from the GitHub side, right? Like what are the steps it's actually following? Well, it's very similar to Dropbox in that there are encrypted and encoded files. But in this case, they're going to get added to a local repository that's going to get pushed up into the remote copy, right, in GitHub. So you see the attacker commits these files to their repo, then the victim's going to download and delete these files and then push those changes up, right? And the victim's going to execute those commands, then upload the results from those tasks. Then the attacker is going to pull those down and delete them. And then they're going to repeat all of these steps for every command that happens, right? So that's how that communication is happening via GitHub. So let's summarize what we just talked about. We saw that GitHub is a code development app, a source code repository app that's abused by adding commits that contain these encrypted and encoded files. If you wanted to simulate the threat actor using this technique, you could do that using tools like C3 and Covenant. And depending on the sophistication level here as well, you might use these tools differently. So if you want to model a low sophisticated or attacker with low sophistication or an unsophisticated threat actor, you just use the default configurations using a tool like Empire C3 and see if your controls can pick that up. If you want to model a moderately sophisticated threat actor, you can customize those configurations a little bit. And if you want to model a highly sophisticated threat actor, a targeted attack in the real world, then you might go ahead and really tune the existing traffic to match what's in the network. So maybe tunnel your commands through the development department instead of the HR department. That way, the likelihood of them using GitHub is more, right? There's a high likelihood. So while we didn't mention these other tools because we don't see them as much, they're also very important to know, to know they exist, right? Azure Outlook C2 abuses Outlook email drafts for C2. GC2 abuses Google Sheets and Google Drives to execute command on its victims. So the commands are actually written as in the cells in the Google Sheets. And then Calida C2 abuses Outlook, OneNote, and Microsoft Teams for C2. So these other tools, maybe the corporate system you're targeting uses these other tools, uses these other cloud applications that you want to kind of blend in with. Maybe you want to use these other tools as well. So let's take a step back and kind of talk about what we covered. We began by talking about what Cloud C2 was. We defined Cloud C2, and we kind of saw some standardizations that exist in the industry today. Then we went ahead and looked at some trends that exist in the wild, right? What are attackers doing? Is this even really happening? We tried to answer those questions, right? And then we finished talking about how we can set this up in our internal network so that we can simulate the threat actor using this tool so that we can check our controls and test our controls and see where the gaps are. Say we did identify a gap, what defenses do we need to put in place, right? First of all, why don't existing security controls pick this up? Why is this hard to detect? Here we have a screen cap of Fiddler running. So Fiddler is that web proxy application that runs on the victim that we saw earlier. While this was running on the victim machine, we also had the malicious relay that was connecting to C3, and we also had the GitHub desktop application running, right? And we just looked at the endpoints, these URLs that these applications were reaching out to. And here you can see the two processes in the endpoints, right? So firstly, both the malicious and benign traffic, right? The benign and Cloud C2 traffic is going to the same domain, api.github.com. This domain is a valid cloud provider domain. It's GitHub's domain. And the traffic to this domain is encrypted using a cloud provider certificate like it would otherwise, right? This is why this is challenging, because these IP addresses associated with api.github.com, the host name api.github.com, you can't put that into a signature feed, into a threat intelligence feed, because there's just so much benign traffic going there. You can't block this out, right? So you need other methods to detect this particular technique. So what can we do to detect this? Firstly, identify and block known malware. I know this is silly to say, but don't even let it get to the Cloud C2 or the C2 stage if you can, because once it gets to the C2 stage, it's going to be pretty challenging to detect. So if you can block this earlier on, definitely try and do that. Secondly, this shut down on me. Sorry about that. You have to kind of move around. Okay. Secondly, if you want to, if you don't see any use for a certain cloud application in your corporate environment, disallow communication to that non-corporate cloud application. Maybe if you can't disallow all communication, maybe what you can do is monitor usages of that cloud application so that you can investigate what happened, right? Thirdly, adequate logging and monitoring. It's so important to make sure you see all the endpoints your processes or the processes on your networks are reaching out to. And this is an OWASP top 10 issue, right? Make sure you have adequate logging and monitoring in place. Fourthly, regular beaconing behavior. Maybe this isn't necessarily malicious, but if you see a certain process beaconing back out at a certain interval, that should be something you'd want to investigate a little bit more. Unsigned application making network connections should be a big giveaway. So if you see that happening in your corporate environment, make sure that you kind of block that. It should not be a common use case, right? Make sure when that happens. User agents that are associated with known malware. So the Empire user agents kind of, it's a little bit static and it doesn't, there aren't a lot of benign users that use that too often. So if you see that, make sure you kind of block that out. The last two are actually we got from AppSecEU's blogs, and they're really good detection. So we wanted to note them here as well. AppSecEU monitored all of the processes and the network connections from these processes across time. And across time, they model the packets that were transferred outside of the corporate network. And you see when an endpoint is compromised, that traffic at that instance of time is going to kind of stand out. So make sure, and this is kind of at the bottom right? So the screen cap at the bottom right, you can kind of see that this compromised endpoint kind of stands out, and you want to use that to identify endpoints that might be potentially compromised. Lastly, the C2 stage is followed by actions on objectives, which is the last stage in the cyber kill chain. This stage is if you're maybe not able to identify the C2 stage because the attacker is low and slow, and it's just beaconing out once a week and you can't identify it. Usually, action on the objective stage is going to require them to, it's typically data exfiltration, right? And they're going to do it over the C2 channel. So if you see large amounts of data moving off your corporate network to an application that you don't see any corporate use for, that should warrant, a lot of alarms going off, and you should kind of dig into that a little bit more. So let's go all the way back and kind of talk about those 4 key points we started with. What is Cloud C2? We defined Cloud C2 as command and control via a cloud application. We saw that we saw a few definitions and a few categorizations that exist in the industry today. And then we went over and talked about which cloud applications are abused through C2. And we saw a vast majority of them can be abused. And we saw some trends and some insights, and we even categorized these apps and saw some features that are abused in each category. Then we went over how you can simulate this in your network. And we went over 2 example applications, Dropbox and GitHub. And we saw we can do this with 4 steps when using a tools like Empire, C3, and Covenant. And then lastly, we talked about what defenses can be put in place. And we saw there's numerous controls that we can put in place to identify and detect Cloud C2, both at the endpoint and the network level, right? And we can use these defenses to kind of help our security posture from a defender standpoint. Awesome. So that brings us to the end of the talk. I know I have a few more minutes to go, but and I'll be happy to start taking questions. But in case kind of ran out, my Twitter handle is @Dagmawi, and my LinkedIn is Mulugeta. We have a bunch of research on cloud application abuse on our blog, so feel free to kind of follow us there. Or if you just really want to talk anything cybersecurity, I'm always open to having these discussions. So please reach out to me. I'll be happy to kind of answer any questions you have. Barring that, thank you very much for attending this talk. And if you have any questions, I'll be happy to start taking them now. Thank you.
Thank you very much, Dagmawi. It was a great presentation, so much interesting content, and thank you very much for sharing it. So I wanted to ask the first question that I have here. Are there any patterns you have noticed with cloud applications, features, and abuse frequency?
Yeah, that's a really good question. Yeah, so this is kind of going back to that slide where we saw maybe I can go back really quick. Yeah, so here we have seen some patterns, right? These attackers are kind of preferring certain categories of cloud applications a little bit more, and they're attacking them at a higher frequency. And these the reason for these cloud storage applications, we kind of went over a few reasons that might be the case. They're easy to get set up and get going. A lot of people use them, so they're very easy to kind of blend into. And then lastly, they integrate really, so the integratability factor is important, to integrate really well into the existing flow they have. So attackers are kind of more enticed to use these category of applications more in their attacker flow. But we will see in the near future, and as time progresses, that a lot of these other categories are also going to start seeing some traffic as well.
Thank you very much. Great.
Awesome.
Thank you. And the second question, is this not something that cloud providers should deal with? Why is this something I, as a defender, have to worry about?
Yeah, that's a really good question, right? Let me answer that in two parts. So firstly, the cloud providers are doing, what they can do to detect this. There's a lot of instances where they have abuse portals and everything, where if you identify abuse of the particular cloud app, you can kind of reach out and let the provider know. They'll bring it down. They have some processes in place, automation in place, kind of identify abusing of their platform. But you have to imagine what it looks like from their angle, right? If we go back to the Dropbox example, the attacker is really uploading a file, downloading a file, deleting a file. From the Dropbox point of view, there's really not much you can do there. That's exactly what you want the application to be used for. It's only when someone says this application is being used to move data off my system that becomes a problem, right? So there's a visibility problem there that it's difficult for the cloud provider to see, especially in targeted attacks, right? So this is why, as a defender, we kind of went over that list of defenses that might help you identify the sort of traffic in your environment.
Thank you very much for your answers. Is anything else you would like to share? Is there any communities that people may join to get more information?
Yeah, absolutely. So accidentally touched on a link. So I have this slide here. So these are my this is my information. That's my Twitter handle, my LinkedIn. Those are the two best places to kind of get additional information on this. So if you kind of reach out to me and get I don't think we're going to give these slide decks out, but if you reach out to me, I'll personally send these slide decks over to you so that you can have the links and the references, etc. And also, if you go to the my research team is the Netscope Threat Lab research team. We have a blog where we talk about all of this stuff on a weekly basis. So we have a bunch of additional, not just C2, but additional cloud application abuse as well. So if you want the latest and greatest in that space, that's that's the best place to reach out to. It's a great question, Svetlana. Thank you.
Thank you very much, Dagmawi. It was so good. It was a very interesting presentation, and I'm sure that people will reach out to you and will ask more questions. So
awesome.
Thank you. Thank you very much. And thank you for being the active part and speaker in this conference.
Yeah. Thank you very much for having me. Appreciate it. I'll stop sharing now and I'll give that throw back to you. Thanks.